No, it will not go. Okay, listen. On section 1.4, you should always kind of read what the objective is and what that essential question is there on the front. The essential question is, how do we solve two-step equations? You should always rate yourself before the lesson, after the lesson, and after your homework assignment. How well do you think that you could solve two-step equations? Do you think you know little or nothing? That's a 0. Do you think you could do maybe a little bit? That might be a 1. With some help, you might be at a 2. Do you think you could do all of them without some help first? That might be a 3. You should rate yourself at the beginning before we do the lesson. You should rate yourself after the lesson. You should rate yourself after you do the assignment. Give yourself an idea how much you're growing. It's a good idea to see that growth. You'll notice the front says, on the bottom, on using your turn, it says use algebra tiles. Do you see algebra tiles in my room?
No.
I have them.
Yeah, I can use them.
I could get them out.
No.
Okay. I'm going to tell you, some people are very successful using algebra tiles. It's been my experience. I have been less successful. Whatever works for each individual teacher, and whatever works for each individual student. If you'd like to know how to use algebra tiles, I gladly would show you sometime in the morning. Okay, come in. If you think it would help you learn how to do them. I'm going to tell you, it's been my experience, it's not been beneficial. It's better to teach you the method of how to add and subtract. Because in the end, when you're taking a standardized test, are they going to provide you with algebra tiles? No. So you need to know how to do the mechanical part of it anyway.
This paper.
Okay. So, if you'll notice, on the bottom of the page, there's 4 your turns. I've pulled 2 of them to work as examples. They did an example using algebra tiles, so you can kind of step by step see what they did. I'm going to do it the other way. And I'm going to tell you, this is so much the same as what we did Friday. There's very little difference. Friday we did 1 step. Today we're doing what? 2 steps. 2 steps. But the goal is the same. What do we want to get by itself?
X.
The variable, whatever it might be.
So we can just put like X equals.
This is what I want to get by itself. And if I look at where it is, they're adding 5 to it. How do I undo addition? Please notice, I did not shortcut writing that step down, did I? Please, don't shortcut it. I had somebody that told me, well, they just did mental math and they figured out what it was going to be. Is that a valid method?
No.
Yeah, you can say that it is. There's nothing wrong with it. If you can put your number in there and make sure it's going to come out, that's okay. Will that method work as the problems get more complicated? It's probably a good idea to learn how to do the steps. Because if you start doing them on the easier problems, you're going to know how to do them as the problems get more complicated. Don't skip showing the steps. If I subtract 5 from both sides, it's going to leave me 2x is equal to 6. X is still being multiplied, so what do I need to do? Divide. And I'm going to divide both sides by 2. And it's going to leave me x is equal to 3. The nice thing to me about algebra is I can find out whether I'm right or wrong. Because I have the ability to check my work, which is doing what? Plug it in. See if it works. 2 times 3 plus 5 equals 11. Well, what is 2 times 3?
6.
And what is 6 plus 5?
11.
And I can see that my answer is going to check, isn't it? It has to be correct. Everybody good with the first example? Okay. A lot different than Friday? Not really. Just an extra step. I picked number 4 for a very specific reason. Because the variable has a negative out in front. And I'm going to tell you year after year after year, time after time I have explained, it's a good idea to circle what you're trying to get by itself. And notice that I included what with it? The sign, the negative that's there. Why? People forget it. And on this problem, it's less forgotten than it would be if it was written this way. It gets forgotten all the time this way. They go ahead and subtract 2 from both sides, and they just bring down what? 4y, but what type of 4y is it? Negative. Be careful, make sure you're attaching the sign. Okay? Because I'm going to tell you that that negative makes a big difference. If by chance you've forgotten the negative, when you go to check it, guess what's going to happen? It's going to show you've got the wrong answer. So, how am I going to get rid of adding 2? Subtract 2 from both sides. It's going to give me 4y, negative 4y, equals negative 4. A negative 2 and a negative 2 both have what? The same sign, right? So I add them together and I keep their sign. Y is being multiplied by a negative 4. What do I have to do? And I've got to divide by a negative 4. Negative divided by negatives make positives. 4 divided by 4 is 1. If I go to check it, what's a negative 4 times 1? What's a negative 4 plus 2? Negative 2. And I can see again that my answer does check. No, the answer is what? Y equals 1. This is just to make sure that my answer did what? Was checked. You know, that I could see that it came out the same. Okay? Questions on those 2 examples? We good so far?
Yes.
All of your problems are going to be similar to that today. But I do want to work out one word problem. You're going to find this on the bottom of page 26. And again, I picked one that was simple mathematical words versus one that was talking about Sally who owned the shop and yada, yada, yada.
How old these triples
are. Okay. I picked this because even the complicated ones include words like this. And we've got to learn how to get from something that's worded mathematically into an equation. And one of the things that I really recommend you do is just go through and circle the words that mathematically mean something, that are important. 5 less. What does that mean? I'm subtracting 5 from something. Okay? Quotient. Quotient means divide, and quotient always will be paired with the word and the division is going to take place right where you see that word and. Okay. Quotient, sum, product, difference. All are paired with the word and their operation will happen where the and is at in the sentence. A number. What's that? It's a what? Variable. 4. Okay. X divided by 4 It said 5 less, so I'm subtracting 5 from that. Mathematically, the word is means equal to. And what is it equal to? 15. There's my equation. How do I undo this subtraction? Addition. I'm going to write my division this way because it looks nicer. X divided by 4, or x over 4, the same thing. How do I get rid of division? Multiplication. My number is 80. A number divided by 4. 80 divided by 4 would be what? 5 less than that would be what? I can see that I came up with the right answer. Ready with me? If you can do the simple ones like this, you'll be able to do the more complicated ones. Because even the more complicated ones use the mathematical words to connect things together. They just add names. They add things like checking accounts or temperature. But they really boil down to the simple mathematical words. We all okay? Your assignment today, then, is on page 29, 6 through 17. All just on solving equations. Okay? No word problems, nothing, just what? Solving two-step equations.